Okay, in this task, we're given a target function here, and it's our job to do two things. One, determine whether or not this represents, this mass is changing according to a cubic function over time or not. And then if it is, we've got to figure out what function is governing the mass. So, if we take a look, we can see it's moving. The two criteria we're looking for is one, does it either have one pause point or exactly two turning points? Okay, so let's just hit play and see, does it have exactly one pause point or does it have exactly two turning points? Well, there's one turning point, so one pause point is out. And there's a second turning point. Now, obviously, we'd have to look at the behavior of the function from negative infinity to infinity. But given the fact that this is kind of decelerating there, turning, kind of accelerating up into a turn there, and now it's accelerating again, it's a good indication that this is cubic. So we're going to assume it is for now. But the second thing we have to determine is, are the third differences constant, right? So we need to collect some data here. Are the third differences constant? Because tons of different functions can have two turning points, and they're not all cubic. So we're going to collect some data. For time 2, we are at a mass of 30. So I've set up a spreadsheet over here. It's like a table. You just use a table on your sheet. So 2 is at 30. Now I'm going to always go on a consistent 2, 3, 4. You got to count consistently over here. We'll go up to 3. And now we're at 51. 4, 54. 5, 45, and 6. In order to get the third differences, we're back at 30 again. In order to get the third differences, we're going to need at least 5 data points to see if the third differences are constant. So you need at least 5. Now we need to calculate the differences. So these will be the first differences, and we do 51 minus 30. The difference here is 21. And then we do 54, a 51 to 54, that's a difference of plus 3. 54 to 45, that's a difference of negative 9, okay? And then 45 down to 30, that's a difference of negative 15. So I've kind of staggered these. These are the differences. Now we need to find the second differences. So the difference from 21 to 3 is negative 18, down 18. From 3 to negative 9, negative 12. And from negative 9 to negative 15, that's a negative 6. Now the third difference is, if we're going from negative 18 to negative 12, that is an increase of positive 6. And negative 12 to negative 6, also an increase of 6. So these are the third differences here, and we can see that they are constant. Now, of course, you'd actually have to check this for all of the points, but we're not going to. This is a really good indication. It's got 2 turning points, and the third differences that we've looked at are the exact same. So this really is looking like a cubic. So that means we've got to fit the data using a cubic fit. So we've got these data points here. With a cubic, with a linear, you need 2 points minimum. With a quadratic, you need 3 points minimum. And with a cubic, you need a minimum of 4 points. There are an infinite number of cubics that can go through 3 points, 2 points. So you need at least 4. So we'll use these 4, 230, 351, etc. We go over to Wolfram. I need to pull this down a little bit so you can see. Put it in the window here. We're going to use data 1 equals 4 points. Put our commas in. It was 230, 351 454 and 545. We could throw the other one in there if we wanted to. I'll leave it at this though. Okay. Shift enter on that, and now we're going to use our handy find fit function. Okay. The first thing we need to put in there is data 1. Second thing we need to put in there is the format for the function. So this is going to be a times x cubed plus b times x squared plus c times x plus d. So now we have 4 constants, a, b, c, and d, comma, we need to tell Wolfram which of these are constants, which are the numbers we're looking for, a, b, c, and d, and which of these variables is the actual variable, and that's x. Shift enter, it tells us a is 1, b is negative 18, 92, and negative 90. So let's go write our function and see if it matches. Negative 18 and 92 and negative 90. So it says that a was 1, so that's just x cubed. Hit enter to get that written in. Negative 18, 92, and 90. Negative 18 x squared 92 and negative 90. 2x minus 90. Moment of truth. Ooh, it snaps in at least for those two. And let's get satisfying, folks. Oh yeah. Feeling good. Perfect. Feels good. Feels good in the hood. So that's it. Figure out whether it's cubic or not. If it is, write the function. If it's not, you don't have to. Bonus if you can.